We will be talking about confidence intervals, calculating them using the T-critical score. This is somewhat different from the first video I did. That one had said calculating confidence intervals using Z-critical score. I just wanted to point out the big difference. We're calculating confidence intervals using T-critical scores. The big difference here is that the standard deviation of the population is unknown. The first video there was an assumption that the standard deviation is known, but in most instances, we don't know the population standard deviation and we may have to resort to this calculation. I have to point out the two stark differences between calculating the confidence intervals when the standard deviation is known and when it is unknown. The column that says before shows what I displayed in the previous video about the z-score when the standard deviation is known. We were using the formula for the standard of error of mean with the standard deviation represented with sigma, that's the little zero with the stick at the top, and we resorted to using the normal standard distribution table. Here, when the standard deviation is unknown, this is after the fact, after the first video, we're going to replace sigma with S because S is what we use to represent the sample standard deviation, and our standard of the error formula now reads, or sigma x bar for a sample is equal to sample divided by the square root of n. In the second difference is that we will be using the student t-distribution table rather than the normal standard distribution table to find our probabilities. Just a quick visual of what the student t-distribution curve would look like. It shows different degrees of freedom, and that's a new term that you're going to come across now. We are going to need the degree of freedom to pull our probabilities from the student t-distribution table, and this is found by subtracting 1 from n. So n is our sample size. If our sample size is 17, then our degree of freedom is going to be 16, 17 minus 1, and we really want to remember that. Now, computing the confidence interval for the mean when the standard deviation is unknown is somewhat similar to the formula we were using before when it was known. This time we replace our z criticals with t criticals, and there's a little delta above our standard error of the mean when we use the sample to calculate that. So we have to calculate the upper control limit and we have to calculate the lower control limit. Once again, our upper control limit has a plus sign, our lower control limit has the subtraction sign. We will be subtracting. So things we would need to calculate this: mean represented by x bar, or a t-critical score, which we're going to take from the table, and our standard error of the mean from a sample, which we can calculate or it's either given to us. Here are 3 simple steps of what to do. Once again, not too different from how we would calculate it if we had known the standard deviation for the population. 1, we're going to compute the standard error of the mean, and this is found by taking our sample and dividing it by the square root of n. 2, we're going to find our t-critical score by using the student t table. And 3, we're going to calculate the upper control limit and the lower control limit in the similar way we did it with the z-score calculations. Here's an example. Ironically, a teacher wants to estimate the average number of hours students spend reviewing their statistics class assignments. Assume that the teacher decides to sample 15 students. The mean of the sample is 6.23, and the sample standard deviation is 0.60. Compute a 95% interval of the sample mean. Notice that we were given the sample standard deviation. We don't know the population standard deviation, and that is our cue for using the student t-distribution table. Let's first record what we know. And once again, this is in note format because I want you to take out your notebooks and I want you to write this down. What do we know? We know that our sample size is 15. We know that our sample standard deviation is 0.60. And we know that our sample mean is 6.23. Let us go through these 3 steps. Step 1, let's calculate the standard error of the sample of all sample means. This is found by taking our standard deviation dividing by the square root of n, and this gives me 0.1549. Step 2, let's compute for t critical, and this is going to be for a 14 degree of freedom, which is found by taking my n minus 1. You need all that information to go and pull the data from the table. The next slide will show you how to do that. So we need T critical for 0.025 because we have a 95% confidence interval. There's 5% significance level, 0.025 on either side of the curve. That amounts to 2.145. Step 3, we're going to compute our upper control limit and our lower control limit. Our upper control limit, the formula is similar to the one that I had posted. We're taking our mean and we're adding our T critical times the standard error of the sample means, and then we're doing the same thing for the lower control limit. This time we're subtracting. So when we put the data for our upper control limit, we get 6.56 hours. When we put in the data for lower control limit, we get 5.90 hours. What does this mean? Well, if you ask me, it means that we're 95% confident that the population mean is between 5.9 and 6.56 study hours for statistics. Here is the student t-distribution table and how I derived that this 95% confidence interval, my t-critical for 0.025 would be 2.145. So if you look along the first column there, take it all the way down to your 14 degree of freedom. Remember, n was 15, so 15 minus 1 gives us 14. And then we move across to that column where we have our 1 tail 0.025 and our 2 tail 0.50 and our confidence level 0.95. That would give us our t-score of 2.145 because we're looking for a 14 degree of freedom and we're looking for a 5% difference 2 tail and a 0.025 difference 1 tail. As usual, there's an Excel function just to calculate the margin of error section of it when a sample standard deviation is used, and here is the Excel function for that. But then you would have to go back and put that into the formulas to calculate the upper control limit and the lower control limit. Once again, here are my tips. Ask the question, what do I know? Write it down. And the second thing, follow the 3 simple steps and practice over and over. I hope you found this video simple and easy to understand. Thank you for watching. Bye.